Hi. So today we will learn magnetism in matter. All the matter, whether it is a compound or it is an element or alloy, all are affected by a magnet and all have magnetic property. And to understand the magnetism of matter, we need to know some physical quantities related to that. I have listed 4 physical quantities, and on the basis of these physical quantities, we can categorize, classify the matter as per their extent of magnetism or the kind of magnetism in those. So, firstly we will discuss magnetization. We know that in an atom, an electron surrounds, revolves. You have, in especially hydrogen atom, we have one proton inside and one electron revolves around a hydrogen atom. And due to revolution of this electron, a current is constituted and it generates a magnetic field. It creates a magnetic field, and so this circulating electron is called a dipole moment. So it is giving you a and this dipole moment is actually your magnetic dipole moment. Has symbol small m. It is a vector quantity. Now, in a bulk material, when we have so many atoms packed close by, so and all have their magnetism, all have their dipole moments. Now, magnetization is given by dipole moment per unit volume, because these dipole moments add each other's effect, and there is net effect, and which is represented by magnetization. So magnetization is dipole moment per unit volume. And it is a vector quantity. Therefore, you can write magnetization in terms of dipole moment per unit volume, and its SI unit of magnetization can be found in this way. Your magnetic dipole moment is written as current into area, I into area, and so for I you have unit ampere, and for area you have meter square. So this is the unit of dipole moment divided by volume. On cancelling this, you have SI unit of magnetization, ampere per meter. So this is your magnetization. Now, second term is magnetic intensity. So you know that magnetic field due to solenoid is given by mu naught Ni. This is the magnetic field inside solenoid. And magnetic field inside solenoid is uniform. So you can see here that this magnetic field is depending on number of turns of solenoid. So it is depending on intrinsic thing of this material, that is number of turn. And there is one extrinsic thing this is your external thing. Current is coming inside. So magnetic field depends on two things. One, intrinsic thing, that is number of turn, and other is extrinsic thing or external thing, that is your current I. And magnetic intensity can be taken as external part, okay, you can write as magnetic intensity is part of magnetic field which depends on external thing. Like current. And does not depend on intrinsic quantities and independent from intrinsic properties, that is number of turns or nature of material. It is free from all these things. Your magnetic intensity does not depend on nature of material, number of turns, all these things. So it is only a part of magnetic field. So magnetic field must be proportional to extrinsic quantity, that is magnetic intensity, and both are your vector quantity. So therefore B naught is equal to mu naught H. Here the constant of proportionality mu naught is equal to permeability of vacuum, permeability of free space. And this is your measure of how any magnetic material is affected by external magnetic field. Permeability is your measure of how the magnetic material is affected by a magnetic field. So this is your magnetic field intensity. It is a vector quantity, as you can see. So now if you place any magnetic material inside solenoid, so due to passing of current, the magnetic material will be magnetized. Previously you had only magnetic field due to solenoid. Now when it get magnetized, then it develops some magnetization. And due to magnetization of this magnetic material, there will be some field due to this magnetization of magnetic material. Let that field be Bm only. So you can see that this magnetic field in the material is produced due to magnetization of the material as it was placed in any external magnetic field. So let me write here. Now a magnetic material is placed in uniform field of solenoid, therefore it gets magnetized. Therefore it gets magnetized and develops certain magnetization. Let it be capital M, vector capital M, and due to this magnetization it develops certain magnetic field. BM, say this is your BM only. Now this magnetic field in magnetic material is developed due to magnetization of the material. So the magnetic field in the material will be proportional to magnetization. Therefore magnetic field is equal to mu naught into M, and here mu naught is a constant called permeability of free space. Now you have two equations you can see here, equation 1 and you have equation 2. Now the field will be, net field will be given by the sum of two magnetic fields, because you have previously the field due to solenoid. Now you have developed a new magnetic field. So this magnetic field will be added in the previous magnetic field. So B net is equal to, actually from here you can write mu naught H plus mu naught M, and this is equal to mu naught into H plus M. This is your B net. Now you will appreciate that this magnetization is only due to the current that is flowing in the solenoid. So magnetization will also depend on the external cause, that is H. So you can write that M is proportional to external cause H, and you may write that M is equal to, this is a constant called chi into H. Let me take certain space. Okay. Here chi, you can call it as chi, is a constant which is susceptibility. of magnetic material. So, firstly, let me define susceptibility. What is susceptibility? Susceptibility is the measure of how the magnetic material is affected in any external magnetic field. So this is your how magnetization of material is related to external cause of magnetic field. So this was about susceptibility. Now next thing, let me put the value of magnetization in this equation A. So your B net becomes equal to H plus, in place of magnetization I am writing chi H. So magnetic field net becomes equal to mu naught 1 plus chi into H, and this is equal to mu naught mu r into H only. Here mu r is called relative permeability, and this quantity mu naught mu r is actually equal to permeability of the material. And therefore your relative permeability is equal to mu upon mu naught. So you can see that it is the ratio of two same thing. So unit is cancelled. So relative permeability is a unitless quantity. We learnt about 4 quantities, and this will help us identify the materials, classify the materials in different groups as per their magnetization. So we learnt 4 quantities: magnetization, magnetic field intensity, then susceptibility, and then finally we learned relative permeability. On the basis of the 4, we can define the materials in 3 groups. all the materials can be classified into three groups: diamagnetic material, paramagnetic material, and ferromagnetic material. If the quantity susceptibility is smaller than 0 and it lies between -1 to 0, then those materials are classified as diamagnetic material. Now, if susceptibility is greater than 0 and it is less than any finite number, when susceptibility is greater than 0, then those materials are classified as paramagnetic material. And if susceptibility is very, very larger than 1, then the substances are classified as ferromagnetic material. Now we learned that your susceptibility plus 1 is equal to relative permeability. So when you write this equation in terms of relative permeability, so you need to add along both the sides this one. So you get this equation.